Hello everyone, welcome back. This is Professor Roldan with Explorations in Math, section 6.1, order of operations and combining like terms, which will prepare us to solve equations at the end of 6.1. Okay, we're also going to do 6.3 in this video for the purposes of applying our equations to solve application problems or word problems or real world problems. All right, well, let's do this. So, order of operations, if you recall, is some people know it as please excuse my dear Aunt Sally or PEMDAS. Okay, so we have 4 orders, and I'll call this the last one. Parentheses, exponents, second, multiplication, division, third, and then add, subtract, last. Now these last two orders, the multiplication, division, and the addition and subtraction, they both come in a tie. So you're going to do both of these in order from left to right. Okay? So that's just a quick reminder. So let's go ahead. I'm going to do the evens here. So odds in class, evens in video. Okay. So in this case, we're going to do, so the word evaluate basically means to find the value of the expression for a given variable. Okay? So, in other words, substitute. So here's our expression. Oops. Negative x squared. And this is saying substitute the x with negative 3 and find the value of that. Okay, so we're going to put negative 3 in here, which means that we're going to do negative 3 times negative 3 is positive 9, and then negative times 9 is going to be negative 9. Okay? Number 4, we have a trinomial, polynomial. And so we need to put negative 2 in for the expression. So anytime there's an x, you're going to put parentheses and insert the value that we're trying to get here. Okay, so this is 4. This is a positive 4. And we have 14. Okay. Number 6, we have an x to the third power and our x to the first power. So we have our expression, and we're going to insert the negative 2 in here. And so you can use your calculator or just do this in your head. Negative 2 times negative 2 times negative 2, that is negative 8 minus 8. And that's going to be same signs, guys. You're going to find the sum of a and 8 is just 16, and keep the sign. okay, because we're on the same side of the number line. Okay, so subtract 8, you're going to go back this way, gives you 16. So if they're the same sign, we're going to add those two digits because they're growing in either the left direction for the negatives, or they're growing in the positive direction if they're both positive. Okay, let's take a look at a solution to an equation. Okay, a solution to an equation is the number that replaces the variable to make the equation a true statement. Okay, so what we're going to do is evaluate this to see if we get a 10. So we're going to put the x right in there. So do we get a 10? On the left side, 16 minus 6, and 16 minus 6 is 10, so we get a true statement. And since that's true, then x equals 2 is a solution to the equation. Okay? So that's how we do that. Let's go ahead and go to the next page. And we have 10 here. And so again, we're going to evaluate with this -3 to see if we get a 10 here. So there. So the question is, are we going to get a 10 from this? So -3 in both spots. So that's positive 9 minus 6 plus 1. 9 minus 6 is 3, and 3 plus 1 is 4, so that is false. So x equals -3 is not a solution. Okay? Now let's take a look at number 12. This is a little different. It has a radical sign there. So this right here means square roots. Okay, so in other words, the answer is what times what, being the same exact number, is going to equal that number 64. And that's just going to be 8. So the square root of 64 we can simplify to 8. And then this is bring down the negative. Oops. Insert our -2 to see if we get 24. Okay. And so we have positive 16 right here. And then we have minus -2 to the third power is going to be a -8. And that's going to be plus plus now, which gives us positive 24. And positive 24 does not equal -24, so this is false. It's not a solution. Okay. Okay, so here's the answer key for the worksheet in your workbook, 6.1 worksheet number 1. All right, now we need to discuss combining like terms before we go into solving equations. So this is done often to simplify the left side of an equation and the right side of an equation, or one or the other, okay? And so there are two requirements for having like terms, and that's going to be the same variable and the same exponent. Okay. So a couple of examples to remind you what that means. Let's say we have x plus 3 minus 8x plus 12. And all we're saying is, okay, let's make this expression simpler by reducing the number of terms. So instead of having 4 terms, let's see if we can combine some of them into one term. So we see that we have x's right here. Those two can be combined to get negative 7x. And these two can be combined to get 15. Okay? So we've made this expression simpler by going from 4 terms to 2 terms. And that's definitely something you want to do if this is an equation and you're trying to solve it. All right, you make it simpler by combining like terms. Another way you can do this, if you don't want to mark it up like I just did, you can also group them together, if that helps. So here's another example. It's kind of long, but basically we can say, hey, this is too long. I want to organize this a little bit better so that I can see the like terms. So we can put the x terms together in a group. We can put the y terms together in a group. And we can put the constant terms together. Okay, so you're definitely more than welcome to group them so you can see that they're side by side. I prefer just to mark them up like this. Maybe put a box around these guys. Maybe put some underlines and whatever you want to do there. Okay, maybe you put 2, doesn't matter. Okay, so regardless of how you do it, the x's go together. And that's going to create a positive 1x. And then negative 5 plus 2y is negative 3y. And then 2 plus 10 is 12. So this is what we mean by combining like terms. So this big thing ended up being more expressed in a simpler fashion using 3 terms. Okay, so now we want to look at solving equations. And in class, I gave out a toolbox for solving equations handout. That's going to basically have all the different variety of tools that you can use to solve various types of linear equations. Okay, and I'll be mentioning them as we go along. So again, I'm going to do the evens. Okay. So here, there's nothing to simplify, all right? Everything is pretty much compact on the left side and the right side. What I mean by left side, I mean here's the left side of the equal sign, and here's the right side. So everything is simplified. So all we just need to do, is isolate the x, okay? Or whatever variable you're trying to solve. So isolate means get by itself. Or alone. Okay? So we're going to subtract 4 from both sides to keep the equation balanced. Okay, so 4 minus 4 is 0. That's why we did that. So we can go away from the left side. It's going to appear on the right side. So the algebra is keeping the equation balanced, and then the math is right there. So here's your math, and then this right here is the algebra. Okay, doing something to solve for x. So 25 minus 4 is 21. And then we want to do the inverse operation again to get rid of this negative 3 so we can get x by itself. So if we divide anything by itself, it's always going to be 1. And 1 is an invisible number next to these x's. So that's why we want to do that. Whatever I do to the left side, I do to the right side. So now my final answer then will be x equals negative 7. Okay, let's take a look at number 4. Okay, so here we have parentheses. So we want to clear those parentheses by distributing, okay? So we want to distribute the 3, and that'll clear those parentheses out. You don't have to rewrite those. Okay. And we basically have a simplified equation here now. We just need to get the variable isolated, okay? So we're going to add 15 to both sides. That's going to give us 30. And we divide both sides by 6. And that's going to give us 5. Okay? But the main thing we did here was get those parentheses out of our scenario. Okay, let's take a look at number 6. So in this case we have, as you can tell, we have a variable on both sides. And the sides, I'm talking about of the equal sign. Okay, so what do we do about variables on both sides? You can't solve it with 2 variables, one on each side. So we need to collect variables. This is in your handout. So it's already simplified on the left and the right, but we need to collect variables to one side. So it's better to choose the smaller of the 2 variables as far as their coefficients concerned, and that just keeps our equation or our variable term positive. You don't have to do it like this, but I like to use the smaller of the 2. Okay, then we finish this up by isolating. And we're done. Okay, so the main strategy here was to collect the variables to one side. There wasn't any simplifying, there weren't any parentheses, and so let's move on. Okay, so in number 8, we have a number of things we're going to be doing here. As you can see, if you observe before you start, we have variables on both sides. We have this, we have the parentheses here that we're going to have to take care of. We're going to have common terms on this left side because it's kind of big. And we're gonna have to combine the 5 with something, probably with this 5 right here. So there's a lot of things going on here. All right. So it's gonna take, this is a multi-step equation. It's gonna take us a while. So the first thing we need to do is, we see parentheses, clear them out. Okay, so distribute. Okay, so now we observe and say, wait a second. This right side is simplified, but over here on the left side, I can put those two together. So our second step is to combine like terms, CLT, on the left, because the right's already done. Okay, so 5 plus 25 is 30. And now we need to, as you can see, we have our variables on both sides here. So I'm going to collect my x's to the left. Whoops. Okay, because 2 is smaller, and if I subtract it here, it goes away. If I subtract it here, I get a positive x, and that's, I don't want to get a negative x. So this is going to be 8x plus 30, bring down everything, and here's our negative 5, who's still left on the right side. And now this is back to like number 2 that we did. So we're just isolating this x here. So let's get this 30 out of here. That gives me negative 35, divide by 8. And now we get negative 35 over 8. Okay, an improper fraction. So it is okay to have fractions, okay? Okay, or decimals in your answer. So don't freak out and think you did this wrong just because it does not divide evenly, okay? So this is perfectly fine. Okay, so why don't you try number 10 on your own? This is pretty much a good test question right here because it puts everything in one problem, a lot of the different techniques and tips. So go ahead and do this, and I will show you the solution in a few minutes. Okay, hopefully you have noticed that the left side equals the right side, and somewhere along the path you notice that. So I'm showing you here in step 3 that negative 2x plus 21 is the same on the left and on the right. So right here we can notice something called an identity. So when you have the left side that matches the right side, we get something called an identity. Okay? And this is going to produce all real numbers. Okay? And again, an identity is just a true statement. Okay? So let's continue with this. You can notice it right here. Or if we continue by collecting x's to one side, and they're both going to cancel out. Giving us 21 equals 21. So there's another identity right there. Either way, gives us the same answer. Or if you want to keep going, we're going to get the same thing. Okay, so either way, any of those three green check marks are the points in which you can see the identity. Okay, so this is a true statement. Okay, so this brings us to how we did number 9 in class, where we got a false statement, and that was no solution. So we have the following scenario. If we get a true statement, that will produce all real numbers. And this scenario is called an identity. Okay? But our solution, our answer is right here. False statement and pretty much you'll see this when the x's cancel out. We have no solution, which this is called a contradiction. Okay? So please remember this as you're doing your work, as if you encounter this scenario. Okay, guys, we have reached number 12. And in number 12, we see some fractions. Now, some people look at fractions and they kind of freak out and say, I don't know what to do with this. Well, some may attempt to do common denominators, which is fine. But that way is actually dealing with the fractions, and I prefer not to deal with the fractions. And so one of the tools in your toolbox that I have listed there is to clear out the fractions, or basically the denominators, by multiplying all the terms by the LCM, the least common multiple. Okay, so that's what we're going to do here. Okay. So the strategy here is to clear out the fractions by multiplying all terms by the LCM. Okay, so what I mean by LCM is least common multiple. Okay, think of the multiples or the times tables, for example, for 5. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. Or in other words, we can just list them. So basically, you can figure out what the LCM is by looking at 5, 10, and 2, but I'm just going to do it the long way. And I'm going to list every number here from least to greatest. I'm going to say, okay, multiples of 2. 2, 4, 6, 8, 10, 12, 5, 10, 15, 20, 10, 20, 30. So you don't have to do it this way, but this is if you're not sure what the concept of least common multiple is. These are the multiples of the numbers 2, 5, and 10. And the L of the acronym means least, or the smallest, or the first set that all three have in common. And as you can see, it's 10 right there. Okay, so hopefully you can get to the point where you can just figure out that number in your head by thinking of 2 can be divided into itself, 2 can be divided into 10, and 5 can be divided into 10 as well. So every single number can be divided into 10, including 10 itself. So if I multiply all the terms, I'm just going to put a 10 next to every single term here. And what that does is creates a division problem. It creates a division problem with the denominators that were making this thing annoying. And so all you got to do is just divide these numbers right here. So basically in the first one we have 10 divided by 5 is 2. Okay, that's the new number that's created. The fraction is gone, but everything else is still involved. 10 divided by 10 is 1. And the 3 is still there. And then we have a 1. And then we have 10 divided by 2, which is 5. So basically what we just created is, and you can do this in your head as well, 4x plus 3 equals 5, which is much nicer than the 2x over 5 plus 3 over 10 equals 1 over 2. Okay, you're more than welcome to deal with those fractions, but here I just cleared out the fractions and now I just have a nice two-step equation here. And then divide by 4. So we get this fraction 2 over 4, which reduces to 1/2. Okay. So this is one way to deal with fractions. Okay. So I'm not going to do 13, but basically, if you don't deal with the fractions in number 13, even though this is odd, you're going to get this ugly mess. But you're going to have to actually okay, and it's just not very pretty here. Keep forgetting that X there. So 20 divided by 5 is 4. So at the beginning, we can take care of this problem by multiplying everything by 15. 15 is the LCM, or the LCD, some people call it. So we're going to put 15. That's one term there. And here's the other term right here. So basically this is going to create 15 divided by 3 is 5. 15 divided by 5 is 3. And then 3 times the 2, that's going to equal 6. Okay, so I don't know about you, but this side looks better than the ones with the fractions. Okay, so it's just something to think about. I hope you follow my advice to get rid of the fractions in the first step, but it's totally up to you how you want to do this. Let's take a look at our last problem. I don't have a 16, so we're just going to do this one. Now, with decimals, again, it can be kind of risky to try to deal with the decimals and keep them in. There's 3 decimals I got to keep track of, and it's not going to be fun because I can put the decimal in the wrong spot on the next line. I can forget about it or just miscalculate. I can type it in my calculator wrong. I mean, there's all kinds of stuff that can go wrong if you don't deal with the decimals now. So I would just rather clear them out. So in this case, we're going to multiply by 100. Now, why did I choose 100? That's because in this problem, the most decimal places is 2. Okay, so if you look here, I got 2 decimal places there, I got 1 decimal place there, and 2 there. So if I have, the most decimal places that I have to clear out happen to be 2 in this case, okay? So there's my 2 decimal places right there, 0, 0 from the 100. So basically, if we multiply by 100, in effect, that is moving the decimal 2 places to the right, 2 places to the right. In this case, I got to put a 0 and 2 places to the right. So now my new nice equation is just going to be 2 minus 40x equals 22. And I don't know about you, but I'd rather deal with those whole numbers than deal with a bunch of decimals everywhere and having to keep track of that. Especially if you don't have a calculator, that can be really annoying. So this is a nice, quick technique. Does not require the use of a calculator to deal with this problem. So we're going to go ahead and finish this up. Trying to isolate the x here, so we're going to subtract 2 from both sides. We're going to divide by negative 40. And that's going to reduce to 1/2. Okay. So this is the last problem for solving equations. So now what I want to do is use our techniques to actually solve a real world problem. Okay, something practical, something we do that we might use in an everyday life. Okay, so I want to go ahead and move on to worksheet number 3, which is 6.3 application of linear equations. Here are the answers for section 2, which is the equation part. Okay, and here is this 1 page of work that we're going to do in the next few minutes here. So first of all, we're going to practice translating. Okay. So the word more than, okay, it means to add 5. Okay, so more than 5 more than x means to add 5 to x, or you can put 5 plus x, doesn't matter. The sum is another addition. So the sum of what? The sum of 5 and x. Okay. The number 3, the number 5 decreased by what? So the number 5 decreased by x. Okay, then we have the product, which is times. So product of what? Well, the product of 5 and x, or we're going to just write 5x. 5 less than x. Now, be careful with this one. 5 minus x, that is incorrect. Okay, because 5 is being subtracted from x. Okay, you're taking the x and you're going to produce 5 less than that x. So in this case, it's in reverse. So we're going to put the x first and take 5 from that. So now that's 5 less than x, okay? The quotient is division, so we're going to use a fraction bar. So the quotient of x and 5, okay? Instead of x divided by 5, okay? This one's used more for solving equations and things like that.